In this video, we're going to build a REST API with Fastify and Prisma. If you've watched one of my previous REST API tutorials, this video is still worth watching. Building an API with Fastify and Prisma is fairly different to building an API with Express and MongoDB. And there is still a lot to learn in this video. So what are we going to be using? We're going to be using Fastify as our web server. We're going to be using Prisma as our database ORM. We're going to be using Zod for request and response validation. We're going to be building Swagger docs. And of course, we're going to be using TypeScript for types and other cool stuff. Before you get started, there's a few things that you're going to need. You're going to need Postman. You should have Prisma Studio, and this is so we can view the data. You're going to need a running instance of PostgreSQL or MySQL. I've linked here to a repository called Awesome Docker Compose, and you will see PostgreSQL in here. If you clone this repository and CD into the PostgreSQL folder, you can run Docker Compose up, and that will start a PostgreSQL server for you. Alternatively, you should be able to download and run PostgreSQL or MySQL locally, but I highly recommend using Docker just because it's so easy. And of course, you're going to need a code editor. I'm going to be using Visual Studio Code. So these are the features that our API is going to have. You're going to be able to create a user. You're going to be able to log in. You're going to be able to list users. You're going to be able to create a product. You're going to be able to list products. We're going to have some authentication. So we're going to make sure the user is logged in before they create a product and before they list users. We're going to have some request and response validation, thanks to Zod. And we're going to have Swagger docs. And this is the video structure that we're going to follow. First up, we're going to have a demonstration of the API. Next, we're going to have a code walkthrough. I think having a code walkthrough is going to help you understand the code when we go to write it, because when we write it, you're not seeing the code for the first time. Then we're going to bootstrap our application. Then we're going to be able to create a user. We're going to list users. We're going to log in. And then we're going to be able to create a product. And then finally, we're going to be able to list products. So let's start with our demonstration. In the description below, you'll see a link to this repository on GitHub. And inside of that repository, you'll see a Fastify Prisma tutorial.postman collection. Copy this JSON and come over to Postman. And you can click File, Import. And then we want to import raw text. And you'll see here that we're importing this collection. Click Import. And then in the collections folder, you're going to see your new collection here. Inside of the collection, we have two folders. We have user and we have product. Inside of user, you're going to have a request for create user, find user, and login. And then in product, you're going to have a request for create product and get products. You need to make sure you have an environment created. So I already have this environment here. To create an environment, click on the little eye icon. You're going to see that you have no active environments. Click add. I'm going to make this tutorial. And then you need to create one variable here, and I'm going to call this host. And then I'm going to create the initial value as HTTP localhost and then pointing to port 3000. There's going to be a few other environment variables. However, there is scripts that are going to create those environment variables for you. So inside of create user, we have this pre-request script here. And this is going to run before we send this create user request. And this is just going to generate a first name and last name. It's going to set an environment variable for name. It's going to generate a random password and set that as an environment variable for password. Then it's going to set an environment variable for email, which is a combination of our first name, last name, and then @example.com. Let's go ahead and send this request here. And you can see here we're getting an error. Cannot get the environment variable host, and that's because we need to select the environment that we created earlier. So I'm going to select my tutorial environment, and now we can send this request. So you can see here that we get a user back, and we get the ID, we get the email, and we get our name. Now that we've created a user, we can go ahead and log in. And you can see that we get an access token back. In our login request, we have one test, and this is going to pass our body and get the access token out of the body. And this is going to set the access token environment variable. So if we have a look up here, you can see that we now have an access token environment variable. If we go over to our find users request, you can see inside of authorization, we require bearer token, and we're using our access token environment variable. So we can send this request and we get back a list of all of our users. Next, we can create a product. You can see here the body for a product is already filled in, so we can create this. And finally, we can get a list of all products. So you can see our product here has some contents, and then our product has an owner, and our owner is the user that created the product. So this Hertha Joanthan is the user that created this last product. So inside of our repository, you're going to see a source folder and a Prisma folder, and then you're going to see this notes markdown file. The notes markdown file is going to contain a few commands. So this is the install command that we're going to run, and you can just copy and paste this instead of pausing the video and trying to type out what I type out and getting it wrong and getting really frustrated. So just clone the repository or go to GitHub and just copy this text here. This next command is to install our dev dependencies. Next, we have a command to initialize Prisma and set our data source to PostgreSQL. And finally, we have a command to migrate our schema. So inside of our Prisma folder, we have a schema.prisma file, and our schema.prisma file is going to contain a database object, and this is going to say what our provider is. In our case, it's Postgres. We're going to have a URL, and this is going to be an environment variable. So if we go into our .env file, you can see here we have a database URL, and this is going to point to our local Postgres instance. Next, we have a product model, and our product model has a few properties here. The interesting property is the owner and the owner ID, and this is because this is a relation to our user. So you can see here that we have a user model, and our user is going to have products, and our product is going to have an owner, which is a user. Next is our source folder, and this is where most of the magic is going to happen. So inside of our source folder, you're going to see an app.ts, and app.ts is going to contain a lot of our application code. So the first thing we're going to do is to initialize Fastify, and then inside of our main function here, we're going to register our Swagger docs. We're going to register all of our schemas, and I'm going to go through what schemas are in a second. We're going to register our routes. So we're going to have two sets of routes. We're going to have user routes, and these are going to have a prefix of /API/users. And then we're going to have our products route, and this is going to have a prefix of /API/products. And finally, we're going to start up our server. And if our server fails to start up, we're just going to disconnect from Prisma. So for our authentication, we're going to use Fastify JWT. So we're going to register Fastify JWT, and we're just going to set the secret to this string here, super secret. You should make yours something a lot more complex than this. And then we're going to use a decorator, and our decorator is going to be authenticate. And this is going to verify our JWT. So if we have a look in one of our modules, I'm going to go into user, and if I go into user routes, you can see we have this route here for getting all users, and we're going to use a pre-handler, and this is going to be server.authenticate, and then server.authenticate is going to run this request.jwt verify, and this is going to verify that this request was made with a valid JSON web token. So next we have our modules folder, and inside of modules we have user and we have product. Inside of user we have a user controller, user routes, a user schema, and a user service. So as requests come in through our application, they're going to go into our routes file. And then from our routes file, we're going to go into a handler, and handlers exist in our controllers folder. And then from our handlers, we're going to call services. So in this register user handler, we're going to call a service called create user. And then inside of our service, we're going to call the database. So the flow is going to be from our route to our controller to our service. And then the next thing is going to be our schemas. So our schemas are Zod objects, and these are going to specify different things. So we have this schema here called create user schema, and this is going to be our payload for creating a user. And then we have a schema for create user response. And this is going to be the response from when you create a user. And with our Zod schemas, we can create types here. So you can see we have this create user input type. And this is a TypeScript type that we've generated from our schema. Next, we're going to export all of our schemas, and we're going to export this ref function. So our schemas are then going to be imported into app.ts. So you can see here that we're importing our user schema and our product schemas. And then we're going to loop through all of those schemas and call server.addSchema to each schema. And because we've done that, those schemas are going to be available throughout our application. So if we come into our user routes here, you can see in our options object, we have a body, and this is going to register our create user schema as the body. And our create user response schema is going to be what we expect our API to respond with. And because we've registered all of these schemas, we can now easily create Swagger documentation. So inside of our main function here, we're going to call server.register, and we're going to register some Swagger documentation, and we're going to pass it some configuration. Let's go over to this docs route here and take a look at what our Swagger documentation is going to look like. So this is our documentation, and you can see we have all of our routes here. One to create a user, one to get all the users, one to log in, one to create a product, and finally to list a product. And if we open this up, you can see we have some example input here, and we have an example response. And finally, down the bottom here, we have all of our schemas that we've registered with our Fastify application. So let's get started building this REST API with Fastify and Prisma. So I'm here in a new VS Code window, and the first thing I'm going to do is to initialize our application with yarn init. Just going to press enter to all these questions. And then I'm going to initialize TypeScript. So I'm going to say npx TypeScript --init. And this is just going to create a tsconfig file for us. The next thing I want to do is to install some dependencies. Again, get this yarn add command from the repository in the description below. Next, I'm going to install my development dependencies. Let's create a new folder, and I'm going to call this folder src. And then inside of our src folder, I'm going to create a new file called app.ts. And I'm just going to console.log hello world. Then to run this file, I'm going to come over to the package.json. I'm going to create a new scripts object. I'm going to call my new script dev. And then I'm going to use TypeScript node dev. So I could say ts node dev, but there's a shorthand for this where I can say ts nd. I'm going to give it a flag of --respawn, another flag of transpile only, another flag of exit child, and then I'm going to tell it to start my app file, which lives in the source directory. So I'm going to say src/app.ts. Let's test this out with yarn dev. And you can see here that we get hello world, and this means that we're good to go. So the first thing we want to do is get our Fastify server running. So I'm going to import Fastify from Fastify. And I'm going to import this with a capital letter. Next, I want to say const server equals Fastify. And then we can execute that. Next, I want to create an async function called main. So I'm going to say async function main. And then just below this function, I'm just going to execute it. Now I want to add a try catch block, and I'm going to start the server inside of this try catch block. So I'm going to say await server.listen, and I'm going to listen on port 3000. And I'm also going to set a host here. So I'm going to set this to 0.0.0.0. And the reason that I'm setting this host is because if you go to deploy this application inside of Docker, you're going to thank me very much for doing that and not just using the default local host, because of course that won't work in Docker. Docker expects your host to be 0.0.0. And then finally, I just want to say console.log server ready at HTTP localhost port 3000. But if we can't start the server, I want to say console.error, and I'm just going to log out our error. And then I'm going to exit the process with process.exit. And I'm going to exit with a process code of 1, which means that we exited with a failure. So let's open up our localhost port 3000. I'm just going to make a request to this inside of Postman. And we should get some sort of response. Here we get a 404, could not find the index route. And this is exactly what we would expect to get. So the first thing we want to do whenever we create a server is to add a health check route. So I'm going to say server.get, and we're going to listen at /health check. And then this is going to take an async function. And inside of our async function, we're going to have a request and we're going to have a response. Then we can just return an object with a status of OK. So if you're familiar with Express, this is not going to look like Express because we can just return out of this async function. Whereas in Express, we're going to have to call this response object with a status, or we can just say .send. We're not actually going to use these, so I'm going to remove them. And let's go over to Postman and try use our health check endpoint. Okay, we get back a status of OK with a 200 response. And this means that our server is up and running. And you can use this endpoint to ping your server and make sure it's up and running at all times. Let's come into our source directory and I'm going to make a new folder. I'm going to call this folder modules. And inside of modules, I'm going to create 2 folders. I'm going to call one user, and I'm going to create another folder called product. And our product and user folder are both going to have their own set of controllers, routes, schemas, and services. So inside of user, I'm going to say user.route.ts, and I'm going to create another folder called user.controller.ts, another folder called user.service.ts, and another folder called user.schema.ts. And inside of our user routes, the first route that we're going to create is to create a user. So I'm going to say async function user routes, and then I'm just going to export default user routes. And our user routes are going to take one argument, and this is going to be our server. And we can type our server with Fastify instance. And this just means that our server is going to be an instance of Fastify. Let's go back to our app.ts and we can import our user routes, import user routes from module/user/user route. Now we can register these routes with server.register. And then we pass in our function. And I want to give these routes a prefix. So I'm going to pass in an object as the second argument. I'm going to say prefix. And I want to prefix all of these routes with API/users. We can come back to our user routes here. And I want to create an endpoint to create a user. So I'm going to say server.post. And we're going to say .post here because this is going to be a request that listens to the post method. And I'm just going to listen on the / route. And the reason that we're just listening on / instead of something like users/create, for example, is because we've prefixed our route with /API/users. And so if we send a post request to this route here, we want to hit this handler. So I want to give this a handler called register user handler. Let's come over to our user controller and I'm going to create this function. I'm going to say async function create user handler. And our create user handler is going to take a request and it's going to take a reply. And we can type out our request and reply. So I can say Fastify request, and our reply is going to be Fastify reply. We also need to export this function. Let's go import register user handler in our user route. So import from /user controller, and we're going to import our register user handler. So now that we have our handler hooked up to our route, we want to be able to create a user inside of our handler, but we don't have any database connection. So let's go initialize Prisma, and so we can start creating our users. So inside of our notes file, we have a command here to initialize Prisma. So I'm going to run that command. And this is going to create a .env file here. And you can see that we have John Doe, random password, localhost, mydb. I'm just going to update this to be Postgres. And then the password is going to be change me. And this is going to be Fastify Prisma tutorial. And this is just going to be the name of our database. So inside of Prisma, you can see that we now have a schema.prisma. And this is where we can define our user and our product models. So I'm going to say model, user, and then our user model is going to have an ID, and the ID is going to be an int. And I'm going to say @ID. And then I'm going to default this to auto increment. So I'm going to say @default. And then inside of our default, I'm going to say auto increment and then execute that function. So this means that our ID is just going to go 1, 2, 3, 4, 5, and so on. Next, we have an email, and our email is going to be of type string. And then we want to put a unique flag on our email as well, because we don't want two users with the same email to be able to register. I'm going to say name. And then name is going to be a string, and name is going to be optional. So I'm just going to put a question mark here. So in our API, we're going to make name mandatory, but I'm just showing you here that you can have optional parameters on your models. Next, we're going to have password, and password is going to be a required string. Then we're going to have salt, and salt is going to be a string. And I'm going to go through what salt is when we go to hash our user's password. So the next model we're going to have is our products model. So I'm going to say model product, and our product model is going to have an ID. So I'm just going to copy this from user, and we're just going to auto increment the ID as well. You could use something like UUID, which is probably actually better than auto incrementing, but auto incrementing here is convenient. Our product is going to have a created at, and this is going to be of type datetime. And I'm going to default this to now. And I'm going to do the same with updated at. I'm just not going to default the updated at. I'm going to set this to updated at. So when we update our product, our updated at property here is going to change. I'm going to have a title, and this is going to be a string. And when we create strings in Prisma, it creates a varchar of some random length. I think it's like 109 or something. But we want to create a varchar of 255. So I'm going to say @db.varchar, and then this is going to be 255. So you can overwrite the default varchar length inside of Prisma with this notation here. I'm going to say content, and content is going to be a string, and it's going to be optional. I'm going to have price, and price is going to be of type float. And next I'm going to have an owner, and this is going to be of type user. And our relation is going to be fields, and we're going to have an owner ID, and we're going to have a reference to the ID field. So Prisma is giving us an error here because owner ID does not exist. So we need to create that as well. I'm going to say owner ID, and this is going to be an int. So Prisma is giving us another error here, and it's telling us that product doesn't exist on the owner. So we need to come back up to the user model here, and we need to say products. And then this is going to be an array of products. And now Prisma is happy. So now that we've defined our schema, we can migrate this up to our database. So when we migrate it, it's going to create a migration file and it's going to run that migration file for us. Let's go into our notes and we can see this npx Prisma migrate dev. Let's run that. So you can see that Prisma has created a new folder here called migrations. And inside of migrations, we have a Unix timestamp here. And then we have the word init, and that's because that's what we called our migration. And then inside of the migration, we have this migration.sql file. And this SQL file is going to contain everything we need to create our database structure. So you can see here we have a create table command for user with the fields that we specified. And then we have a create table for product. And you can see here that we have a product primary key, which is our ID. And then we have a unique index for our user's email address. And then we're going to add the foreign key to the product table so we can reference our owner. Okay, so the next thing to do for Prisma is to create a Prisma connection. So inside of our source directory, I'm going to create a new file. I'm going to call this utils. And then inside of utils, I'm going to create one file. I'm going to call this prisma.ts. And then I'm going to import Prisma client from @Prisma client. Then I'm going to say const Prisma is equal to new Prisma client. And then we need to execute that function. Then we can export default Prisma. And then we can use this Prisma instance throughout our application. So if we come back to our user service here, we can create a new function called create user. And we need to export this as a async function. We're going to take some input here. Now we can say const user is equal to await Prisma. And we can import Prisma from our utils directory. .user.create. And then our create function is going to take one object. And then the first property here is going to be data. And then our input is going to be the data. So you can see here that we get some really good typings on our Prisma object here. So if we command click on user, you can see that we have a user object here. And we have a bunch of functions that are all typed out for us on our user object. This is really cool. And we're going to get this for everything that we put inside of our Prisma schema for free. So we get a bunch of types that we can use and they come out of the box with Prisma. So we have one problem here and this input isn't typed. So you might be tempted to say, type this input with whatever create is going to take. But the problem with that is if we command click on create, you can see that we have user create args here. So this is looking promising, but then user create args, if we could go into that, is going to have some things that we don't want to include in our arguments here. So for example, we don't want to include products in this argument. And if we had a created at and updated arguments here, we wouldn't want to include those either. So we can create our own inputs and we can use Zod for that. So let's go into our user schema. And it might feel like we're going all over the place at the moment, and that's because we are. And it's going to get a little bit more defined later on, and we're going to be able to follow a pretty linear sequence, which is going to make the code read a lot easier. And the tutorial is going to get a little bit easier to follow as we go along. So bear with me if you think that we're going all over the place at the moment. Let's say const create user schema is equal to Z, and we can import Z from Zod. So import Z as a named argument from Zod. Then our create user schema is going to be Z.object. Then we're going to have an email, which is going to be of type Z.string. .email. Then we're going to have a name, which is going to be Z.string. And then we're going to have a password, which is going to be Z.string. So these are the properties that we expect the user to pass in for us. So let's add some error messages here. So we can say if they don't provide an email, we're going to have a required error. And we're just going to say email is required. And then we can say invalid type error. We say email must be a string. Let's do the same for password. So I'm just going to copy these down here, and then I'm going to replace email with password. Now we can export a type from our schema here. So I'm going to export type, create user input equals z.infer. And then we say type of create user schema. So I have one little problem here. Infer is actually a type, not a function. So we need to use our greater than and less than signs. So now let's use this create user input inside of our user service. So I'm going to say input is create user input. So we're getting one problem here, and that is because our salt doesn't exist, but our user object requires a salt. So let's go create a function to hash our passwords. So usually you would use something like bcrypt or argon2 to hash your passwords, but I'm not going to do that in this tutorial. I'm going to create a function from scratch to hash and verify our passwords. Now, I don't recommend you do this in production. I just think this is a little bit more interesting than using a library like every other tutorial. And you're probably going to learn a little something about Node's crypto module. So let's create a new file inside of our utils folder. And I'm going to call this file hash.ts. And our hash file is going to have two functions. So I'm going to say export function hash password. And then we're going to export another function called verify password. So I'm going to say export function verify password. And I'm also going to import crypto from crypto. Okay, so the first thing to do is to create a salt. And a salt is a random piece of data that we're going to add to the user's password and hash it along with the user's password. And this is going to guarantee that every password in our database is unique. So if two people have the password, the hash of that would be exactly the same. And if someone managed to crack that password, they would see that hash and they would know that their password is password. But if we add a random piece of data, or a salt, then those two users' passwords are going to be unique. And just because one password is cracked, it doesn't necessarily mean that the next password will be cracked. So I'm going to say salt is equal to crypto.random bytes. And I want to create 16 bits of random bytes. And then I'm going to say toString. And I want this to be in hexadecimal format. So now this salt is just going to be a random string of 16 characters in length. Next, we can create the hash. So I'm going to say const hash is equal to crypto.pb_kdf to sync. And this function also needs to take a password, which is of type string. And this function here is going to take a few different pieces of information. So you can see here that it's going to take a password, it's going to take a salt, it's going to take our iterations, our key length, and our digest. So first off, we're going to put in our password. Then we're going to pass in our salt. And then the iterations that we're going to do is 1,000. And then the next argument is going to be our key length. So this is going to be 64. And then our digest is going to be SHA-512. And then finally, we just want to return our hash and our salt. So to verify our password, we want to take in a few arguments. Our first one is going to be a password. The next one is going to be our salt. And then the next one is going to be our hash. So our password here is actually a candidate password. This is the password that the user provided to us. And then we're going to verify that that password is correct. So I'm going to rename this to candidate password. And I'm going to make all of these inputs an object. Now we can type these out. They're all actually going to be strings. So I'm going to say candidate password is a string. Salt is going to be a string. And hash is going to be a string. And then I'm going to spell candidate correctly. So basically we want to hash this candidate password just like we did up the top here. So I'm just going to copy this function here and I'm going to rename this to candidate hash. And we're going to pass in our candidate password. And then I just want to return candidate hash is equal to a hash. So we have one little error here, and this is always going to return false because buffer and string have no overlap. The problem is we need to convert our hash now to a string, and we want this to be in hex format again. And we need to copy this up to our hash password as well because we need our hash here to be a string as well. So how this is going to work is the user is going to register. We're going to generate a random piece of salt. And then we're going to hash their password along with the salt. And then we're going to store the hash with the user. When the user comes to log in, they're going to provide a candidate password. And we're going to provide the salt from the user's profile. And then we're going to hash the candidate password with the salt. And we know the salt is correct because we've got it off the user object. And then if that hash matches the hash that we've stored on the user up here, then we know that the password that they have provided us is correct. If they provide us with any other password other than the one that we created from our hash password, we know that their password is not correct, and our verify password will then return false. Let's come back into our user service, and I'm going to get our password out. So I'm going to say password, and then I'm going to get the rest of the properties with our REST operator equals input. Next, I want to say const equals hash password, and I want to pass in our password. And hash password is going to return a hash, and it's going to return a salt. So now our input down here, we need to replace with our REST operator, and we can spread that. Then we need to provide our salt. And you can see that Prisma is still not happy because we haven't provided a password property, but we don't want to use this password here. We want to use our new hash. I'm going to say password, and this is equal to our hash. Finally, let's just return our user. Let's come back to our user controller and we can start filling this in now. So we can say const body is equal to request.body. Then we can say try const user is equal to await create user, and we can pass in our body. We're going to catch this error in console.log out of error, and then if we face an error, I'm going to return reply.code, and we can set a status code here. I'm just going to set the status code of 500, but you should probably check these errors to see what the error actually was. So if you have a conflict, for example, if a user tries to register with an email that already exists, then you're going to want to send back a status 409 because we have a conflict and not a 500 error. And then we can just send back our error. If we manage to create our user, we want to return with a reply.code, and we want to set a status code of 201, which is created. We've managed to create the user resource. And then we want to send the user back. So TypeScript is complaining here, and it's saying that type of unknown is not assignable to email, name, password. So the reason for this is because our request.body is of type unknown. So the way that we can type our request in Fastify is really easy. And if you've used this in Express before, this is going to be a refreshing change from Express. So we need to open up our generic brackets here and provide an object. And then we simply need to say body. And then our body is going to be create user input. So this is our create user controller and service complete. We should be able to go over to Postman now and create a user. So let's go try this out. So I'm going to come over to my create user endpoint. I'm going to send this, and you can see that we get back a bunch of data, including our password and our salt. Even though our password is hashed here, we don't want to be able to send that back, and we definitely do not want to send the salt back. So how can we fix this? Well, we could just omit the password from the user before we send it back, but that can get a little bit messy. We don't want to have to do that every single time we make a request. Instead, we want to use a schema to say what we should be replying with. So let's come back into our user schemas, and I want to say const create user response schema is equal to z.object. And we're going to have some overlaps here. So we're going to have an email and a name. So let's cut those out. I'm going to say const user core equal to an object. And then I'm just going to paste these in. And then inside of our create user schema, we can now spread our user core. And our create user schema now is going to, by default, include our email and name. But then we can reuse our user core here down with our create user schema. We also get back an ID, and we want to get that ID back. So let's define that as well. I'm going to say ID is going to be z.number. So we need to attach this schema to our routes to say only respond with these properties. And the way that we're going to do that is with a Fastify plugin called Fastify Zod. So I'm going to import from Fastify Zod, and I'm going to import build JSON schemas. Next, I'm going to say export const equals build JSON schemas. And then build JSON schemas is going to take a single object as the argument, and then we can start passing our schemas in. So I'm going to pass in our create user schema, and then I'm going to pass in our create user response schema. Our build JSON schemas is going to return two properties. The first one is going to be our schemas, and I want to rename this property to user schemas. And then the second argument is going to be our $ref. So now we need to register our schemas, and then we can reference our schemas inside of our routes. Let's go back over to our app.js, and I want to import from modules/user/user.schema, and I want to import our user schema. And then I want to register this schema. So inside of our main function, I'm going to say for const schema of user schemas. Then I'm going to call server.register. And I'm going to register the schema. So I just need to pass that into this register function here. So the function we need to call is not register, it's server.add schema. So it's important that you register these schemas or add these schemas before you register your routes. If we did this the other way around, this wouldn't work at all. So now that we've registered our schemas, we can go back into our routes. And after we define a path, we can define an object, and this is going to be our options. So I'm going to say schema, and then schema is going to be an object. I'm going to say body, and then we now need to use our ref. So I'm going to say $ref, and VS Code is going to import this for me from our user schema. And if we open some quotations here, you can see that we get some nice typings. So this is going to be our create user schema. We also want to define a response. So I'm going to say response, and this is going to be our status code of 201. We need to define a ref, and this ref is going to be our create user response schema. Okay, so let's go play around with this. I'm going to send off our request, and you can see here, body should have required property ID. What we've done here is I've put the ID on our create user schema instead of our create user response schema. Let's send this and try again. You can see now that we don't get our password or our salt back. And the reason is because our response is going to be passed through Zod, and Zod's going to say, well, the password and the salt don't live on the schema. Therefore, I'm going to omit them from the response. We can do the same here. If we go into our user controller and I console.log this body, and then we define a property on here, let's say ID, and our ID is going to be 999. Let's send this request. You can see that ID doesn't exist on the body, and that's because Zod has admitted it. So this body here has been sanitized for us, and that is a really nice feature of Fastify Zod. And personally, I think that feature is good enough for me to want to use Fastify in the future over Express. Okay, now let's go create a route for logging in. So before we do this, I want to set up our Fastify JWT plugin and our authenticate decorator. So I'm going to come back to app.ts and I'm just going to import fjwt from Fastify JWT. You can call this whatever you want. You could call this Fastify JWT if you liked, but I think fjwt is good enough. Next, I want to register this plugin. So I'm going to say server.register fjwt, and then we're going to have a secret here. And I'm just going to make my secret a random bunch of characters. And we'll get rid of the space here. Next, we want to create a decorator. So I'm going to say server.decorate. And I want to call my decorate authenticate. You could just call yours auth if you like. Then we have an async callback. And our async callback is going to take a request and a reply. And we can type these out with a Fastify request and a Fastify reply. And VS Code hasn't imported these for me, so I'm going to have to do that manually. Okay, so wherever we use this decorator, we're now going to run this function here. So I want to say try, catch. And if we catch an error, I want to return reply.send error. And the function that we want to run is await server.jwt verify. And we're getting a little error here that says JWT verify does not exist on our Fastify instance. And that is absolutely correct. It actually exists on our request. So let's go back to our routes, and I'm just going to collapse this route here. And I'm going to say server.post. And this route is going to be /login. I'm going to have some options here, and then I'm going to have a login handler. Let's go create this login handler in our user controller. So export async function login handler. We're going to have a request, which is going to be of type Fastify request. We're going to have a reply, which is going to be of type Fastify reply. Before we go any further with our handler, let's go back into our schemas. And I want to create two new schemas, one for our login request and one for our login response. So I'm going to say const login schema is equal to z.object. And to log in, we require a username and a password. Sorry, we require an email and a password. So let's just copy our email from up here. And then I want to say password, going to be z.string. And in Zod, by default, things are required. So you can see here that our create user input, everything is required, even though we didn't say like .required or anything. So let's add our login schema to our build JSON schemas. And then I say const login response schema is equal to z.object. And then we're just going to have one property here, and this is going to be an access token. And this is going to be z.string. And we need to add this schema as well. So if we come back into our user controller, we can type out our request here. So I can say that we have a body, and this is going to be login request. And we need to add our type for login request. So I'm just going to copy our create user input, and I'm going to call this login input, and it's going to infer the type from our login schema. Grab this, come back over to our controller. Then we can import this type from our schemas. Then I can say const body is equal to request.body. And our body here should be of type email and password. So what do we want to do to log a user in? We want to find a user by email. We want to verify password. And then we want to generate access token. And then we want to respond. So this is the happy path. Obviously, there's going to be an error if their password is wrong or the user can't be found, for example. We need a service to find the user by the email. So let's come into our services. And I'm going to export a new async function called find user by email. And this is going to take an email, which is of course type string. Then we're going to return Prisma .user.find unique. You'll notice that Prisma doesn't have a find method. It's going to go to find first or find unique. They're the only two options. You can also find many, but we just want to find one user where their email is equal to the email provided in the function's arguments. So const user is equal to await find user by email. It's a body.email. Then we say if not user reply dot code. It's going to be a 401 dot send. And then we're going to send a message that just says invalid email or password. And we're going to be intentionally vague with this message here. So if they get their password wrong, we're just going to return the same message because we want to tell people what users we have in our system. Next, we want to verify their password. So I'm going to say const correct password is equal to verify password. And this is going to come from a hash function that we created earlier. Next, we want to pass in our candidate password, which is going to be body.password. Then we want to pass in our salt that we're going to get off our user object here. So I'm going to say user.salt. Then I want to pass in our hash, which is going to be user.password. Instead of storing the password as .password, you could store it as something like password hash if you keep wondering why it's called password and not like hash or something. Then we want to say if correct password. Now we want to generate a JSON web token. So I'm going to say const equal to user. And I want to take the password and the salt out of the user. And then I'm just going to get the rest of the properties. And I'm going to return access token is going to be equal to whatever we create our JSON web token as. So to create a JSON web token, we can use a function on our server property. So if we use server.jwt.sign, we can sign a JWT like this, but we don't have access to our server inside of our controller. So we can do that by exporting this server object. Then we can come into our user controller again, and we can say server.jwt.sign. And then we just want to sign a JWT with the rest of our user properties. Otherwise, we just want to reply with a 401, it says invalid email or password. Okay, let's go try this out. So I have login here and I'm going to send this request. And it says we got a 404, and I think this is because I may not have saved our routes file. So login handler. And actually, let's fill in our schemas as well before we try this out. So I say schema, and we have a body, and our body is going to be ref login schema, and then our response is going to be 200, and this is going to be ref login response schema. Okay, now we can go try this out. And you can see that we get a valid access token back. Let's go have a look at what the content of this access token is. So I'm going to come over to jwt.io. And you can see that we have an ID, an email address, a name, and a date. Okay, perfect. So let's create a route where we can use our JSON Web Token. So I'm going to say server.get, and then we're just going to get at the root. So this is going to be /API/users. Then I'm going to have a handler that's called get users handler. Let's go create this handler. Export async function, get users handler. I'm going to say const users, it's equal to wait get find users. And we need to create this find users function, but for now we can just return users. Let's create this function inside of our services. I'm going to say export async function find users. I'm going to return prisma.users.findMany. Let's import this function into our controller. Now let's import our handler into our routes. And let's go test this endpoint out. So we can come over to our find users request here, and you can see that we send a bunch of data back, including the user's passwords and their salt. So there's two ways we could fix this. One, we could define what we want returned inside of a schema, but I think you would already know how to do that. Let's go define what we want to be returned inside of Prisma. We can come into our find users service here. And I'm going to pass in an object. I'm going to say select. And then I want to select the email, set that to true. I want to select the name, set that to true. Then I want to select the ID, set that to true. Now if we come back, we can send this again, and we only get back the email, the name, and the ID. But now let's authenticate this route. So I'm going to come back into our routes. I'm going to pass in an object as a second argument into the route. It's a pre-handler. So pre-handler is going to get called before we call our async handler. This is going to be an array, and I'm going to say server.authenticate. And we get a little TypeScript error here. And the reason is because authenticate doesn't exist on our Fastify instance. So we could say something like, and authenticate, and we can say that's a function and all that sort of stuff. But we're going to have to do that inside of every single route handler, and that's going to get pretty tedious. So let's say globally that authenticate is going to exist on our Fastify instance. So I'm going to come back to app.ts, and you can define this anywhere inside of your application. So it might be better to have a types file, but I'm just going to define it in our app.ts. I'm going to say declare module Fastify. Then I'm going to export interface Fastify instance. And then Fastify instance is going to have our authenticate method. And then I'm just going to say this is equal to any. So if we come back into our user routes, you can see that authenticate now exists on our server object. Let's come back and try our newly authenticated route. You can see we send this request and it works. Let's come into authorization, and I can remove our access token here, send this request, and it says no authorization was found in the request headers. Let's set this to a random string, and it says the token is malformed. So we have our API now checking our access token. So in the next part of the tutorial, we're going to work on our products. So inside of our products module, I'm going to create 4 files, and they're going to match our 4 files that we have in our user module. So I'm going to say product.controller.ts, product.service.ts, product.controller.ts, product.schema.ts, and finally product.route.ts. Let's first define our product schemas. So we know we're going to have two endpoints. We're going to have an endpoint for creating a product, and then we're going to have an endpoint for listing out products. So I'm going to import Z from Zod. Then I'm going to import build JSON schema from Fastify Zod. Build JSON schemas. Let's say const create product schema is equal to z.object. Then we're going to have create product response schema. Then we're going to have product response schema. And then we're going to have const products response schema. So this product here is going to be a single product, and then this products response schema is going to be when we return multiple products. So this is just going to be an array of our product response schema. So I'm going to say equals z.array, and then it's just going to be an array of our product response schema. We need one type. I'm going to say export type create product input equal to z.infer type of create product schema. Next, I want to say export const equals build JSON schema, and then I want to pass my schemas in. So I'm going to say create product schema, create product response schema, and products response schema. So if we had an endpoint for getting a single product, then we would export this product response schema. In fact, we can add it in, but I'm not going to build out that endpoint because I think you will be able to figure out how to build that endpoint yourself after watching this tutorial. Okay, so we're going to have some overlap in these objects. So let's create two different objects at the top here. So I'm going to say const product input schema equals, actually, I'm just going to call this product input. And these are going to be the properties that are input by the user. And then I'm going to have const product generated equals, and these are going to be the properties that are generated for a product. So generated properties are going to be ID, which is going to be z.number. Then we're going to have created at, which is going to be z.string. And then we're going to have updated at, which is going to be z.string. And if we have a look at our Prisma schema here, you can see that we have three properties that a user can create. They can create a title, the content, and the price. So let's add those. So I'm going to say title z.string, price z.string, and then the content going to be z.string, and the content is going to be optional because we have a little question mark here. So I'm just going to say .optional. Okay, so now we can use these two objects to build out our schemas. So product input, I'm just going to spread that on create product input. Our product response schema is going to be a combination of the two. So it's going to be product input and product generated. And our product response schema is actually going to be the same. So now I'm going to rename create product response schema to just be product response. And this is just going to be every time we respond with a product. So we can remove that schema altogether, and then we can reuse this schema here for our responding to when we create a product and responding to when we respond with a single product and when we respond with an array of products. So finally, we need to export our schemas, and this is going to be product schemas, and of course our ref. Let's go into app.ts, and we need to register these schemas. So I'm going to get them from product. These are going to be product schemas. And down where we register our user schemas, we could add another for loop here, but I'm just going to create another array. I'm going to spread our user schemas, then I'm going to spread our product schemas. And that's just going to do them all in one big loop. Okay, let's go over to our services. And I'm going to have two services, one for creating a product and then another service for getting a product. So I'm going to say export async function create product. And our data here is going to be create product input. And we're also going to have an owner ID, which is going to be a number. So we don't want the users to specify the owner ID. We want to infer that from the JSON web token that they provide. Let's just return Prisma. And we can import that from utils.product.create. And we're going to create this with our data. We have an error here, and it's telling us that string is not assignable to type number. And if we go have a look in our schema, we can see title is a string, price is also a string, but price should be a number. So let's redefine that, and yeah, so that makes TypeScript happy. The next function is going to be to get an array of products. So I'm going to say export function get products. I'm going to return prisma.products.find many. And I want to provide a selection of things to return. So I'm going to say select, and I want to select the content. So I'm going to set that to true. I want to select the title, set that to true. I want to select the price. And I want to select the ID. But I also want to select the owner. So we can say owner. And then in the owner, we don't want to select all the fields because again, we don't want to reveal the password hash or the salt. So then I'm going to say select. I want to select their name. True. And I just want to select their ID as well. So let's set that to true. Okay, so let's make our controllers to use these services. So I'm going to say export async function create product handler. We're going to have a request and a reply. Our request is going to be Fastify request. And our reply is going to be a Fastify reply. So our create function is fairly simple. We basically just want to say const product is equal to await create product, and we can get that from our service. We want to spread on our request.body, but we also need to supply an owner ID. So I can say owner ID is equal to request.user.id. And then we can return our product. The TypeScript is giving us two errors here. It's saying that our body is of type unknown and our ID does not exist on request.user. So fixing our body types is easy. We can say body is going to be create product input. So we can fix our ID here by doing what we did before and declaring a module. And the module that we need to redeclare is our Fastify JWT module. So I'm going to say declare module Fastify JWT interface Fastify JWT. And then I'm going to say user And if we have a look at our user type in JSON Web Token, you can see we have an email, a name, and we should have an ID on there as well. We need to make sure we do put that on there. So we can say email is equal to a string. Name is equal to a string. We can also say ID is equal to a string. Let's go double check our user controller where we're logging in. And we're finding the user by the email. And we're selecting all the fields. And we're not taking the ID off. So the ID should exist on the JSON Web Token. But we should verify that if we have any errors when creating our product. And we have a problem here. It says string is not assignable to type number. And that's because owner ID is actually a number, whereas we have it defined as a string. So let's redefine that. And you can see that our product controller is now happy. We can actually get rid of our reply here because we're not going to use it. And let's go ahead and hook this route up. So I'm going to say async function product routes. Then I'm going to say server, and this is going to be of type Fastify instance. I'm going to say server.post. And this is going to be on our root because we're going to register our routes with /API/products. Let's export our products routes, export default product routes. Define an options object where we can define our schema. And then our handler is going to be create product handler. In our pre-handler, I'm going to say we have an array. I'm going to say server.authenticate. And that's because we only want authenticated users to be able to create products. I'm going to say schema. And our body is going to be ref. And then this is going to be create product schema. And then we have a response. And we're going to respond with a status code of 201 because we've created a product. I'm going to say ref. And this is going to be product response schema. Make sure you don't do products response schema. It's a single product. Okay, let's try create a product. So I'm going to send this request and we get a 404, the route not found. And that is because in our app, we haven't registered our product routes. So I'm going to register those now by importing the routes. And then just below our user routes, I can register our product routes. And I'm going to prefix these with /API/products. Let's try this again. And you can see that we've created a product successfully. Now let's create another endpoint for listing out our products. So inside of our product routes, I'm going to say server.get, and I'm just going to listen on the root of /API/products. I'm going to define a schema, and then I'm going to have a handler called get products handler. Let's define our get products handler. So export async function get products handler. And this is going to be quite simple. I'm just going to say const products equal to await get products. And then I'm just going to return our products. Import this handler into our routes. Let's define our schema here. So I'm going to say schema. And I'm just going to define a response. So I'm going to say response. And we're going to respond with a 200. And the 200 is going to be ref products response schema. Don't forget that this is plural products because we're going to respond with more than one product. Let's try this out. And if we go to our get products route here, We can send this and we get a 500 error, created at is required. So I think the issue is if we have a look here, we've defined this as create at inside of our Prisma schema, but we have created at inside of our Zod schema. So what we can do here is we can go into Prisma Studio, and I'm going to select this schema. And now that I have Prisma Studio open, I can select our products, and now I can see the data in our products table. So I'm just going to delete this one record we have. I'm going to move this to another window. Now we can come into our Prisma schema, and we should be able to fix our products schema here. So I'm going to say created at. And next we need to create a new migration file. So I'm going to create a new migration file by copying this command here. And we've successfully created a new migration. So you can see now we have 2 migrations inside of our migrations folder. And our latest migration just runs an alter table products where we're going to add the column created at. And we're going to drop the old column called create at. So let's go back to Postman and we're going to try create a product. And we're going to get a really weird error here. So let's stop our server and we can restart it. And now we go back to Postman and we try create a product, and our product is now created successfully. If you ever see that weird error where your application is not lining up with your schema, even though you migrated it, just stop the application and start it up again. So you can see here now we have our created at fields and it's named correctly. Let's try and list out our products. So we're still getting this error. And this is probably something to do with our schema not lining up with what we've selected in Prisma. So let's go back and have a look at our get products. And yep, we haven't selected created at, and we haven't selected updated at. Let's try this again. And now we get back our cool product. Let's create a few more instances of this product. And we get back all of our products here. Okay, so this is really good. We've got our application up and running and we have a few endpoints. The last thing to do would be to document our application. So usually creating Swagger docs is a painful nightmare, but there is a nice Fastify plugin that makes this really, really easy. Let's come back to our app.ts and I'm going to import Swagger from Fastify Swagger. And I also need to import with ref resolver. So import from Fastify Zod. And from Fastify Zod, I'm going to import with ref resolver. Let's come back down into our main function. I'm going to say server.register. And I'm going to register our Swagger plugin. And then I'm going to say with ref resolver. And then we need to execute with ref resolver, and we need to pass in a few properties. So I'm going to say route prefix, and I'm going to prefix our route with /docs. You could say something like Swagger, or you could say open API or something, but I think /docs is a nice route. I'm going to set expose route to true, and this is going to expose the docs route. I'm going to set static CSP to true, and this is going to enable content security policy headers for static resources. Then I want to define some open API properties. So I'm going to say open API. I'm going to say info, title, Fastify API. I'm going to have a description. My description is going to be API for some products. And then we want to have a version. So you could hard code the version in here if you wanted. I could say this is version 1.1.1. However, we manage versions inside of our package.json. So we should just use the version that we have listed inside of our package.json. So we can do that by importing from package.json. It's going to import from package.json, and I'll import the version. TypeScript is not allowing us to do this, and this is because we need to set the resolve JSON module to true. This is quite easy. We just go into tsconfig, we look for that property, and we just uncomment it, and it's set to true. So you can see now that we can import our package and we can import our version number. So when we run something like npm version patch, it's going to update the version inside of our docs as well. Okay, so let's go have a look at our documentation. So we have our 5 routes here, and we have our schemas as you saw in the demonstration. So that is a Fastify REST API with Prisma. If you enjoyed this video, please make sure you leave a thumbs up and subscribe to my channel so you make sure you get notified whenever I release videos. If you have any questions or you just want to join the Tom Does Tech community, make sure you join the Discord server. You'll find the invite link in the description below. I would also appreciate it if you request videos in here. This video that you've just watched was requested just last week from a user inside of the Discord server. Thank you for watching, and I'll see you in the next video.